this looks like the right agenda. That took me a bit off. Okay. I'm Chris. As you might have guessed, I'm the leader of a very interesting life. And I'm also, or part of that is that I'm founder of BitCrowd. We are an awesome team of Elixir enthusiasts, and we're doing Elixir applications. We've done machine learning projects, I think, since 2018, mostly in the health sector. And we also do development consulting. So if you want to speed up your team, talk to us. But that's not what I'm about to talk to you. I'm going to talk about Retrieval Augmented Generation and Elixir in the modern world. You know, Elixir is not quite that. It's just a nerdy teenager in a very small town, and Python has just gotten a brand new sports car. And the cool kids in that Python Cabrio are going over and say like, "Hey, Elixir, are you AI ready yet?" And Elixir says, "No, of course I am." Because the future is not about how you run your new LLM, but it's more about the systems that you build with this LLM. We see that in the with the big LLMs that that we use online, that they behave quite more like systems that run things on the side and start sub-process and do routing under the hood than like a normal LLM. Yeah, and Elixir is jumping right in there because while the cool kids are running down with their car because it breaks down, because it was just, the engineering was just not production ready, we have the solid sports car that can deliver all those processes and is rock solid for this kind of tasks. But although we have a great base for engineering, the adoption of Elixir itself is also interlinked with the adoption of AI. Like, how can we integrate that, and how can we integrate the coding experience into our daily lives? And how can we use that to maybe crack one of the problems that we have been facing over the last years, or the last decades, and that is like legacy code bases. This is where rag.code comes in. If you're playing around with code editors and you have something like cursor running or windsurf or Z or whatever, you might have seen a setting like this. If you don't turn that off, your code is already like submitted there, at least for a short while. We will see how that is. And this allows these editors to interlink with your code and to answer questions that are specific to your code base. So it can generate an answer that actually matches. Who here has set up a Retrieval Augmented Generation system already? Okay. Who here knows roughly what it is? Who here knows exactly what it is? Who doesn't have a clue? Okay, this one is for you. That's the wrong side. You know this here, probably, this whole generation, or like you know a slide like this. The AI does generation based on the previous on the previous words and counts the predictability from that. That means whatever we put in this context will influence the generation that happens after that deeply. And you will understand this diagram in just 5 minutes, I promise. I don't know how it was with you, but I was quite okay with math at school, but I had this handicap. I never did my homework. And when I then showed up to the exams, I was sometimes sitting there and wondering, like, oh my God, I've never seen this before. And this is a bit like this LLM, like the robot here in the example, that is quite well trained and it knows everything about math, but it just hasn't seen the exam that it has in front of it. Wouldn't it be better if the exam would be taking part in a library and where he was unsupervised, so he could just walk over and take a book and read about it? The problem with that is the library is vast. It's huge. And the time is running out. So even better it would be if he had an index, something where it could look up like which book is in relevance. And even better still, it would be great if there would be something like this small piece here on the side, a cheat sheet that has all the important bits and pieces and maybe some example surveys in there. So if we go back to our diagram, the normal generation, when we talk with a large language model, is that we have this prompt, and that it has a small window where we can just insert our query, and then the generation starts from that. You know, like this, some slides back, that's the seed for our generation. So if the LLM we ask the LLM something about our code, it just doesn't know what it's like talking about. So it would be great to have this cheat sheet. And we can only get that out of our library. Maybe we have something like an index, but we need this cheat sheet. And how do we get to that? There's this magic link called augmentation, where you embed, where you use an embedding database to retrieve the matching samples from the database. So you know, like from all the books that are in the library, you exactly need page 5. And this magic is happening through the embedding models. An embedding model is a model that is trained to place similar content into similar places in its vector store. So if you place something like car, it will put it here, and it will put bus in here, and it was just trained in that way, so that it puts things in different areas. And when you search something, you do the same thing. You embed that with this embedding model. You find a similar spot in the vector database, and then you do a circling search around that. And then you get the chunks that you want to place into your generation. And then there is this small part here that's the context, how we call it. The context is then filled up with those documents, and that's where the generation starts. And because we have like poisoned our context with such important information, it makes it harder for the LLM to hallucinate, because it has so much good seeds to go on. This is many use cases. Semantic search is one of them. You can use the same technique that you embed things to store things in the database, and then just encode other things to find that out. So you can find can find public transport, although the database only contains documents about cars and bicycles. You can also do classification of incoming requests, and you can even do things like routing on LLM systems. And you can use that also on codebases. We found retrieval augmented generation so important that we decided to release a library in Elixir. However, we found that people were just not interacting with it. So I started to do talks, and I was wondering what library I should use to demo it. And then Tessie came along and said hey, use Ecto. And then later on, Hugo came along and said, hey, why don't you make that a public service? And so we did. We found that idea great. And so we launched xmeralda.chat 6 weeks ago during the ElixirConf in Braga. Just to find out if people would be interested, if people would interact with it. And it's a chatbot that you can use to ask questions to HexPM packages. And the people liked it. It's a very, very standard RAG. The code is also open source, you can have a look. It's quite powerful. And we have some user base that's using it as a bridge between Google and ChatGPT, if you want to say so. Because if you go to do a Google search, then it's often difficult to find the right document. And if you go to ChatGPT, it's often too broad what the answers are. We used the standard building blocks with that. And it has some limitations. It's still hallucinating, and it tries to code more often than it's good for itself, because it only has a small language model to do that. But it's running on monthly costs 50 cents, and the answers are quite well. And it's not at all optimized. You see here, that's the system, that's the prompt template that's running at the moment. So we left it like that because we thought maybe then someone comes along and makes a pull request. Maybe we can tease people to do that. They didn't, or no one did, so we have to optimize it ourselves. We'll be optimizing it with the data that we got, because getting data is the most crucial thing. But it's a great tool to get people interested. And we will do workshops and blog posts with that. So why are we doing all this? The idea is to raise awareness for AI in Elixir, and also to make it possible that people are interacting with legacy system. Because that's like one of the biggest hurdles. If you come to a legacy code base that has no tests and is probably not well written, then in the past there was no way around like either rewriting it or doing some clever techniques to refresh that, to like Mikado technique or anything. But nowadays you can use this AI that can understand parts of the code to do those boring tasks. And that is quite unlocking, because you can now do the first step that you need for the refactoring on an automated way. And you can avoid a bit this code assistant pain that you sometimes feel, because like, I don't know if it's how it is with you, but I always often feel like coding with code assistants is like brings you very fast somewhere. It's like driving through a jungle with 100 miles per hour and the steering wheel often goes off. And then you say like, no, hold, and then it's already passed. Instead, what I find is most likely more helpful is pair programming, so that we have an experience in coding with the LLM that is more like having a coworker on Slack. So what's needed for that? In the classical RAG, the Retrieval Augmented Generation only has access to the documents, or like to the code base itself and to the documentation. That means if you have few, very little comments, and if you don't have much documentation, the answers will not be great. Like here we're trying to ask where the ingestion is taking place, and we see from the answer that it's like doesn't have enough to go on. But if you do things like adding commit messages and including information from Git and from the code management system, then you suddenly find that the answers get better. It suddenly knows like where in the file something is happening, or like where in the code base something is happening, and can point you to the right direction. But if you ask it like things on the side, like what does the acceptance of the terms of services have to do with lawyers, it might still be at a loss. But if you add more side information to it, then it might find that there is a pull request which quite clearly states that the lawyer said we should make the users accept the terms of service. Although the wording was a bit different there. Wrap up. RAG systems can increase your code reading speed immensely. They can crack the legacy problem, and they can run on a local server, so that they can integrate well into the dev environment. They need to be tailored to your code base, on the other hand, because we don't have this whole team of 100 developers that are constantly improving that. So it means like if you want to do it on your own code base, you need to be more, you need to do all this work specifically for your code base. that's it from me. So please play around with Tidewave and Ash and Esmeralda, and yeah, also like try to build your own MCP servers. They are quite powerful and allow you to connect to your IDE. Okay, thank you very much.
All right, so we got a question from the audience. How would one be? Okay, how would scaling work for such a tool for such a big? How would scaling such a tool work for a big repository, like a monolith or a large commit history?
Come again?
Yeah, like how would you scale a tool?
Ah, okay. The good thing is that if you have a large code base, then you don't need to, it will not change like drastically all over every day. So you can do that incrementally. You don't need to drop all the things that are in the database because you can, you know what has been changed. If you do a pull request, then you know exactly like which files were touched. And you can remove them from the data store because the vector database is in itself not dependent on the previous records that were inserted. The only challenge with that is that you need to know like which of those files you inserted, and you need to be careful to remove them.
And another question. Can you share a little bit about the AST and how it relates to this work?
Mm-hmm. I haven't tried that out myself, but there are people who are using AST, like the abstract syntax tree, to find similar code pieces. That means you convert the code that you have into an abstract syntax tree, put that into the vector database, and then you find out the part in the query that actually concerns code, and then translate that to the AST and use that for embedding.